Let's start by adding new functionality to our dApp that will allow suppliers to add items. First of all, let me show you how the item looks like. Here we have a simple JSON with some parameters like title, coupon price, old price of the item, new price, which you will get if you buy this coupon, the address, some description, and link to an image. This is our simple item for our coupon marketplace. So we will need a dApp which will store the information, the data about all the items, about all the suppliers. So we need a function definitely which allow suppliers to add items to the marketplace, right? So this function should accept at least some parameters like title, price, and I guess all other data we can store as one parameter, and we can just write as a blob in our key value storage, as a blob, as a binary, or as a stringified JSON. So before we store the data in our JSON, we also have to perform some checks and validations. We have to check certain conditions like the price is more than 0 and the item does not already exist in the storage. So we can go to the smart contract code and see that I already defined an add item function which accepts title as string, price as integer, and all other fields as an arbitrary data. The main challenge here is not just to validate parameters, but to store all this data with proper keys. So we have to implement some constructions of keys. We cannot save all the data in one key value pair as JSON, as a blob, because you cannot parse JSON in write code. So we will have to find another way to store the valuable data. And the most convenient way to do this is to store each piece of valuable data as separate key value pair. So let me explain. I have an example how it can look like in our key value storage, in the dApps key value storage. For example, for every item, we will create 3 different keys and 3 different values, of course. The first one is item's owner, and we store the address of the supplier. The second one is the price, and all other parameters we store as a stringified JSON. So for every item in our key value storage, we will have these 3 key value pairs, at least these 3 key value pairs. But here you can see some random string. What is it? We will need some kind of unique identifier for every item. We can use a concatenation of supplier's public key and the title of the item, for example, or supplier's address and the title. So we may say that let's use the address and the title of the item. Let's say here's an example of item. So we will get this like an ID of every item. But here is a tricky point. Keys in the storage have a limit of 100 characters. So it is a good idea not just to concatenate strings, but also to take a hash of that string value. That guarantees that the length of the string will always be a constant value and not more than 100. So we will get a hash from this string and use it as an item ID. So the easiest way to implement it, let me show you how it works. So we have a function which accepts 2 parameters, supplier's address or public key as a string, and title of the item. And we convert this string to bytes, get the SHA-256 hash of that string, and convert it back to base 58 representation. And here is an example of the hash. The length of the hash is 44 characters. So we will always have less than 100 characters as a key. So everything should be fine. Also, we will store the address is one parameter. We store price and we store data. Great. Now let's move to actual code in our write script. As I already said, we have an add item function which is callable. All other functions are not callable, so we can use them only inside this callable function. Nobody can call these functions. Also, I define one variable in the global scope. I call it known, just to use as an empty value in the storage, because you cannot store, for example, null or something like that in the storage. So we will store this string as an empty value. Great. Now we will get the supplier's address using pretty familiar operations. We use this string in a wallet example. We saw this in wallet example. And we will get the item ID by calling this getKeyItem function, which concatenates two strings, gets hash from that string, and returns it with prefix item. And also, we will need another key. We will need the price key. We have item ID plus underscore price. And we have a key for our arbitrary data, like item ID plus underscore data. Looks very simple, right? So let's go through the code step by step. We get supplier's address. We make a new item ID by using supplier's address and title of an item. We check that the price is not less than 0. So if it is less than 0, then we will throw an exception with this text. And if this item does not already exist in the storage, then we will write 3 key value pairs, as in this example. Pretty simple logic, and it should work. How to check that it works? First of all, we have to write tests. Here I have a simple example of a test. I define here one item and try to invoke that add item function in our smart contract. But I didn't provide here a dApp address because I didn't deploy this script yet. I will do it in the next lesson. Now I just want you to show how to write proper scripts. It is a good idea to write scripts right after the write code. So here we have invoke script function. We pass dApp address. We call add item function with 3 arguments. The first argument is a title. Let's check. Title is the first argument. Price is the second argument. Oh, let me get back to price is the second argument. And some blob data, some stringified JSON is the last argument. Here is it. Well, looks like all parameters are correct. So we can try to run this code and to get the result, but we are not going to do that. We will do that in the next lesson after the implementation of purchase function in our dApp.